Hello students, welcome to this video session. I am Dr. M. Amuda, Associate Professor of Chemistry, V.V. Vaniya Perumal College for Women, Virudhunagar. In this video session, we are going to discuss about the water technology. First of all, we should know what is the natural source of water, then structure of water, properties of water, determination of hardness of water, then chemical treatment of water. These all are the contents which are going to be discussed in this session. First, we should know what is water. Water is an inorganic substance, that is the molecular formula of water is H2O. This is colorless, odorless and transparent liquid substance. This substance, that means then water has triple point. That means at a particular temperature, this water consists of in three states: solid, liquid and gaseous states. Okay, then what is the structure of water? Water is the tetrahedral structure is with sp3 hybridization. That means two hydrogen atoms are directly linked with oxygen atom, then two lone pairs of electrons are attached in this oxygen atom. These two are lone pairs. These two hydrogens are attached with oxygen atom with bond pair. So due to bond pair and lone pair repulsion, the tetrahedral shape is converted into V shape. So the bent V shape is the structure of water molecule. Next, what is the resource of water? Water storage in ice and snow. You all know about the ice cubes of water, that is snow, that water melt and becomes a water. Then ground storage of water, that is groundwater discharge. Then water storage in ocean. Then water storage in the atmosphere. So these four important sources are for the water molecule. Then by applying four mechanisms, that means precipitation, sedimentation, sublimation and evaporation, transportation are the important mechanism that converts the water sources into the common day-to-day life. Okay, what are the important properties of water? pH, hardness, chemical oxygen demand and biological oxygen demand. What is pH? pH is the amount of hydrogen content which is present in that water. At pH 7 is the normal point of water. Less than 7, the water becomes acidity. That means that is a sour taste, some hydrochloric acid and sulfuric acid may be included in this water. When it increases the pH of water, it becomes basicity. That means sodium hydroxide or potassium hydroxide may be higher level in water. Okay, then hardness. What is hardness? Hardness means some calcium, magnesium substances, calcium chloride, calcium sulfate, magnesium sulfate are dissolved when compared to the excess water. Then chemical oxygen demand, biological oxygen demand are discussed in detail in the next slides. Okay, what are hardness of water? Hardness means there are two types of hardness: temporary hardness and permanent hardness. For temporary hardness, bicarbonate substances are higher when compared to other chlorides. Sodium bicarbonate, magnesium bicarbonate are the main reason for the temporary hardness. Suppose if we want to clear that temporary hardness, we have to just heat that water. That during the heating, the substance, that means the bicarbonate substance which are dissolved in water is heated and evaporated as carbon dioxide. Then the water becomes pure water or soft water. When it compared to permanent hardness, calcium and magnesium substances, that means calcium chloride, calcium sulfate, magnesium sulfate, the quantity of that substances are above 75 mg per liter. Up to 75 mg per liter, the water is considered as soft water or normal water. When it increases, that means up to 150, it is moderately considered. Then above 150 up to 300, it is hard water. More than 300, very hard water. That means it could not be used in any form of our day-to-day life. Okay. When we use that hard water, stains in zinc and tub. Then clothes wear out easily. Then dull colors of clothes. Then white chalky residue on dishes and pipes. Dry skin and dry hair when we use for day-to-day life, that our dry skin and dry hair is appear, then hard water will not form, lather with soap. So hard water should be avoided. How do we determine the hard water? We have to avoid that hard water. Water softeners were used, then ion exchanges, that means sodium hydrogen ions were removed by using zeolites as the resins. Then calcium magnesium substances are rechanged or ion exchanged. This +2 oxidation state are exchanged by some normal substances, then that water becomes normal water or soft water. Then reverse osmosis, some semi-permeable membrane have been used to control the hardness of water or to control the ions. That means the ions are absorbed within that semi-permeable membrane. After the filtrate, that water becomes soft water. Then chemical treatment, how do we chemically control that water? That means how do we determine the hardness? That means calcium chloride and magnesium chloride, calcium sulfate and magnesium sulfate by chemical methods. EDTA titration is an important chemical method to identify the hardness level. If we take, this is the burette, in this burette EDTA is taken in the burette, then conical flask is used. In this conical flask, so 20 ml of water is added here, then Muroxide indicator is added, it becomes wine red color. After the titration, the end point is blue color. So the EDTA consumes the amount of calcium and magnesium which is present in that water. So by a reading taken from that burette, we can calculate the hardness of water by applying the calculations. This is sample collection, then sample preparation, then third step titration. EDTA is used, then EDTA is taken in the burette as already told, then the burette reading is noted up to that 60 ppm. That ppm means parts per million. This is the unit to measure the softness of water. Up to 60 ppm it is soft water, up to 120 moderable, 180 to 250, above 250 very hard water. Okay, then thus we can calculate the hardness level of that water. Then interpretation, by applying some formulas we can calculate the hardness level and identify the hardness of that water, whether it is used for drinking purpose or it is used for agricultural purpose. Okay, then biological oxygen demand. What is BOD? BOD means biological oxygen demand. That means how much amount of the oxygen is just dissolved in that water and is consumed for decomposition of organic matter. That is called biological oxygen demand. This is an important quality whether it is used for drinking purpose or not. Because today we are using water in so many industries. Some effluent which are treated after that effluent which consumed by the regular run of the stream of water. So it may pollute the water. To identify the pollution level, we have to justify the biological oxygen demand and chemical oxygen demand. Then BOD means biological oxygen demand, COD means chemical oxygen demand. Here, this is the biological oxygen demand analyzing setup. In this water, some equipments are attached with this water. By using water and some chemical substances, that means oxidizing agents which are mixed with that compound, and it is incubated for 3 days. After that, we have to analyze the biological oxygen demand of water. Then chemical oxygen demand. Chemical oxygen demand means how the water can be used, or for oxygen level of water is dissolved by oxidation methods. That means chemical oxygen demand. Here we are taking, how do we analyze the chemical oxygen demand? We are taking water as well as the effluent water, then adding oxidation agent, that is potassium dichromate. After that, some sulfuric acid is mixed with, then heated for 150 degree for few minutes. After that, we have to add the ferroin indicator, then the color becomes green. After that, the substance which is taken in the burette is ferrous ammonium sulfate, FAS. Ferrous ammonium sulfate is treated with the effluent water and we can get the wine red color as a or brick red color water. That is the end point of the water to identify the chemical oxygen demand. After that, we are applying some correction value, then we can get the final chemical oxygen demand value. If the chemical oxygen demand value is higher than 20, it is not usable for day-to-day life usages. Then what are the differences between biological oxygen demand and chemical oxygen demand? This means just the water which is used to decompose the microbes biologically, that is called as biological oxygen demand. Here, oxygen required to break down the organic matter by chemical oxidation, that is chemical oxygen demand. It is used for 5 days. That means the substance which are identify the BOD is taking for 5 days. For this one, we can get within 1 hour the result of chemical oxygen demand. When compared to chemical oxygen demand, BOD is somewhat lower. Then it is used to identify the loading of treatment of plant, then evolution of BOD removal efficiency of this water. It provides a measurement on how an effluent will affect that water body. So, BOD and COD, that means biological oxygen demand and chemical oxygen demand. These two are very important parameter to identify the water treatment of any type of waters. Okay girls, now in the next class we will move on to the other techniques of water treatment. Okay, thank you.